Praise the Lord. Hi everybody. Welcome you all to this next session on online classes of 2nd PUC Mathematics. Dear students, today I'm going to take you through the 13th chapter in your 2nd PUC Mathematics called Probability. Okay. This is one of the beautiful chapter in your 2nd PUC Mathematics. This is also the last chapter in your 2nd PUC Mathematics syllabus. Many people believe that this is one of the tough chapter, but I believe but this is the one of the very easiest chapter in your 2nd PUC mathematics. But only thing is you have to use your brain for this. If you can use your common sense and think about this chapter, this is a very easy chapter for you. And one more thing, my dear students, not just for exam point of view, if you are attending any government examinations, if you are taking any recruitments of government jobs, you would definitely have questions on probability. Okay, so I'm not going to waste your time. I'm going to directly take you to the probability. But before that, dear students, we know that in your first PUC mathematics also, you had probability as a chapter, and there you had all the basics and definitions of probability. Now before I go into the 2nd PUC part of probability, I'll just take you through the basic definitions of probability, and then we can directly go into the 2nd PUC concept of probability. Okay, fine. Are you ready? Okay students, now let us go through the basic definitions of probability. Now first of all, what probability means? Basically, the main definition of probability is the chance of occurrence of an event is called probability. For example, you may think of whether it would rain today, or let me say that you are going to take your examination, you are going to pass that examination, or else you are attempting a question. What are the chances of you attempt solving the question or you not solving the question? So in this way, probability is the chance of occurrence of an event. Okay, the other way of saying defining probability is a probability is a number between 0 and 1, remember, representing how likely it is that an event will occur. Okay, usually when you think of an event A, probability of an event A is denoted by number of favorable cases, that is number of favorable outcomes divided by total number of all possible outcomes. Okay, and this is one of the definite formula in probability which we're going to see later. Okay, coming to the next definition, we define something called random experiment. You're going to hear these kind of words in the questions. Okay, so that when you come across these words, you should know what they mean. Okay, so a random experiment is an experiment whose outcome is not known until it is observed. Okay, usually in physics or chemistry or biology you do a lot of experiments, but in mathematics we do basic experiments just like tossing a coin, throwing a die, or picking a card, playing card. So these are the basic experiments which you are going to do in this chapter. Okay, moving on to the next one, this is one of the very important definition. We define something called sample space. Okay, what is a sample space? A sample space is a set of all possible outcomes of a random experiment. As I told you, when a random experiment is conducted, what are the all possible chances? When you put it into a set, that will become a sample space. Okay, so every possible outcome must be listed once and only once. Means you whatever the outcomes are, you have to write just only once. Okay, so sample space is the set of all possible outcomes of a random experiment. So random experiment, I've already told you what it means. Okay, next we go to sample points. So what are sample points? So the elements of sample space are called sample points. Okay, so whenever we say a sample space, okay, in the sample space there would be a lot of outcomes. So each outcome you call it as an element of sample space. Okay, is it clear? For an instance, dear students, let us assume that you are tossing a coin. Okay, rather I say an unbiased coin. Okay, so if you're tossing a coin, now let me say, you can look here, the coin usually has two faces. One you rather call it as head, the other one is tail. Now I'm going to take you through what do you mean by unbiased coin. An unbiased coin is a coin which has both head and tails, two different faces in a single coin. Okay, so when you're tossing a coin once, we know that the sample points, that is the sample space, contain the all possible outcomes. When you're tossing a coin once, okay, let me say tossing a coin once. So if you're tossing a coin once, so the sample space would be either you get a head or you get a tail. That is when you're tossing a coin once. Okay, now in case if you're tossing a coin twice, okay, remember when you're tossing a coin twice, you might have seen this in your previous classes. You may get both heads, which you noted down as head and head, or you can get first time head and then a tail, or you can get a tail and a head, or you can get both as tails. Okay, so in this case, this is the sample space which will contain all possible outcomes. Now remember, each outcome, the both heads or head and tail, this each outcome is called a sample point. Okay, now remember my students, I'm going to give you a small hint while calculating the number of outcomes in throwing a in throwing a coin. Always remember, while throwing a coin, the total number of points, sample points, okay, the total number of points would always be 2 power n. Okay, because the possible outcomes of a coin is only 2, so it is 2 power n. So if you're tossing a coin once, it will be 2 power 1, so you have 2 outcomes. Okay, so if you're tossing a coin twice, you're going to get 2 square, which is nothing but 4 outcomes. You can see here the 4 outcomes are as this. Okay, now in case if you're tossing a coin thrice, let me say, if you're so when you're tossing a coin thrice or 3 times, remember your sample space will have 2 power how much? So it is 2 power 3. You have to have 8 outcomes. Okay, the sample space will have 8 outcomes. Remember, so the outcomes would be as this. You may get all the 3 as heads, or you can get head, head and a tail, or you can get head, tail and head, or you can get head, tail, tail. These are the 4. The other 4 will start with tails. You'll get tail, head and head. Next, tail, head, tail, tail, tail and head. Finally, all the 3 as tails. Okay, so these are the all possible outcomes when you're tossing a coin. Okay, so this is one of the experiment. Now similarly, let me take the second experiment. What we are going to do is throwing a die. Throwing a dice. Okay, when you are throwing a dice, you might have seen, you might have played this also while playing your games. You generally throw a die. Okay, and we know die will have 6 numbers. This is just different colors of dice. You will have all the 6 numbers in a dice, starting from, you can think 1, 2, next 3, right? 4, next you have 5, and finally 6. Okay, therefore remember the all possible outcomes, the sample space of throwing a die once would be, you get 1, 2, 3, 4, 5 and 6. Okay, remember this is throwing a die once. Again, as I told you, dear students, in throwing a die, there is a hint over there in what is the possible outcomes you are going to get. Remember, since in a die there are total number of outcomes is 6, so total number of outcomes would be 6 power n. Okay, so remember, when you're throwing where n indicates how many times it is thrown. When you're throwing a die once, you will get 6 power 1, that is 6 possible outcomes. Okay, in case, let me say you are throwing a die twice, or let me say you are throwing two dice at a time. So if you throw 2 dice at a time, I got 2 and 3. So in this way, what are the all possible chances you get? As I told you, so when you're throwing a dice twice, you'll get 6 power 2. That is nothing but 36 possible outcomes. So which are those? I'll just give you a small hint because you already know it. It would be 1 1, it would be 1 2, 1 3, 1 4, 1 5, and 1 6. Okay, similarly, you start with 2 1 and go on up to 2 6. You start with 3 1 and go on up to 3 6. This will go on to 4 1, 5 1, and finally 6 1, 6 2, 6 3 up to 6 comma 6. So which will give you 36 total outcomes. Okay, so this you've already seen it in the previous classes. So now each item here, each outcome would be known as a sample point. Is it clear, dear students? So this is the basic idea of what a sample space is and a sample point is. Okay, now we are moving on to the next definitions. The next definition we have is an event or events. Okay, a subset of sample space, that is any collection of outcomes, forms an event. That is, example, when two coins are twice tossed. Just now I told you when two coins are tossed, you get 4 possible outcomes. When I say an event, exactly one head. Okay, I want an event which I say I want exactly one head, or I can ask for 2 heads. So according to that, I will get an event. So whatever I ask for will become an event here. Now in this case, I've considered the example as exactly one head. And so the outcomes would be head and tail or tail and head. Okay, this is a very important definition because this topic, we're going to see a lot of events over there. Okay, next definition we're going to see is a complementary event. Complementary event is also called not an event. For example, the probability of India winning a game, if I know the probability of winning a game, then I can easily say the probability of not winning a game, that is probability of losing a game. Okay, so if A is the set, then A dash is its complement. Similarly would be its event. Okay, even A is a set, A dash is its complement. Similarly, if A is an event, A dash would be its complementary event. Okay, now going on to the simple event, any event that contains only one member of a sample space is called a sample point. In another way, if I say whichever event which has only one possible outcome is called a simple event. For example, when you think of throwing a coin 2 times, that is tossing a coin 2 times, if I think of an event getting 2 heads, you just have one possible chance, which is head-head. So that is a simple event. Okay, going on to the next event, you have a compound event. When an event is decomposable into a number of simple events, then it is called a compound event. It's very easily understandable here. Okay, when you can decompose into simple events, then that would become a compound event. Now next definition we have is favorable event. The number of outcomes which results in the happening of desired event. I repeat, the number of outcomes which results in happening of a desired event is called favorable events. Okay, we also call it as favorable events. Now next, going on to the unfavorable event. So if this is the opposite of favorable. Okay, so the complement of favorable event is an unfavorable event. Now remember, these are two very important definitions. We define something called mutually exclusive events. Mutually exclusive events are also called disjoint events. Okay, why I say this is, events are said to be mutually exclusive when the happening of one excludes the happening of the other. That is, no two events can occur simultaneously. For example, when you think of tossing a coin, you cannot get both head and tail at the same time in the single coin. Okay, you should either get tail or you should either get head, isn't it? So these are called mutually exclusive events. For example, as I told you, you should either get head or a tail in the experiment of tossing a coin. Similarly, if you think of throwing a die. So when you think of throwing a die, getting in each number is mutually exclusive. Okay, so if I think of one die, if I've got 1, that means I cannot get any other number. Okay, let me throw it once again. I got 3. Now because I got 3, I cannot get 6 at the same time. Okay, now I may think of again tossing it with the other one. Now again I got 3, that means I cannot get another number. Now you can think of again getting, now you got 6. Okay, since I got 6, I cannot get any other number. So this is called mutually exclusive. The name itself indicates mutually means each other, exclusive means if one is present, the other one cannot be present. Now, the other thing is equally likely events. Very important definition this is. Events are said to be equally likely if each event has the same chance of occurrence. Now, as I told you, in throwing a die, each number has the same chance of occurring. Okay, so if you just shuffle it and throw a die, each number has the same chance of occurring. Okay, so this is called equally likely. Similarly with tossing a coin. When you're tossing a coin, head and tail both have same chance of occurrence. So we say head and tail are equally likely events. Okay, now one more thing is independent events. Now we are going to see this concept in detail in your second PUC mathematics. Okay, what do you mean by independent events? Two different events are said to be independent when occurrence of one event has no effect on the probability of the other event. Okay, that means think of two events. Okay, if one event is depending on other event, then that is independent events. If they are not depending, then they are called independent events. So once you know the independent events, the opposite of it would be dependent events. So two different events are said to be dependent when occurrence of one event has an effect on the probability on the other. Okay, when one event has already occurred, then it will affect the other one. Okay, then we say both the events are dependent. Okay, now the next one is exhaustive events. Exhaustive events are all possible events that can result from an experiment. Okay, all the possible events. For example, when I'm throwing a coin twice, okay, you can see here when I'm throwing a coin twice, one event is getting both the heads, the other event is getting both the tails, the next event is one head and one tail. That is like first one may be tail and the second one may be head, or the vice versa, the other way around. First one may be head and second one may be tail. So all the three possible events together are called as exhaustive events. Is it clear? Next we define called union of events. Now remember, this is very, very important. In this year, you are going to come across this and or cases. Please be very careful, dear students. Whenever we see union of events, it is A or B. Whenever we say A or B, or means union and means intersection. Okay, so A union B means A or B. So A and B means A intersection B, right? Okay, moving on to the next definition. What is a sure event? So an event A is said to be sure event if probability A is exactly 1. Remember, probability is a number 0 to 1. 1 means 100%. Okay, usually the probability of a value cannot exceed 1 because 1 is like 100. Okay, when I say 60%, 60% means 0.60. Okay, so the probability cannot exceed 1. If it is exceeding 1, then there is some mistake over there. Going on to the one last definition from the last year. So impossible event. So if P of A is equal to 1 is called a sure event. If P of an event is 0, then it is called impossible event. Now you might be wondering how it is possible. Now the question is, when I'm tossing a coin, can I get a number 1, 2, 3, 4, 5, 6? Is it possible? It is not possible because in a coin we have either head or tail. In a dice you get any of the 6 numbers. So at the same time, when I think of throwing a dice and to get a tail or a head, that is an impossible event. Okay, right? Okay, so with this we have covered the basic definitions from the first PUC. Now we are going into the second PUC concepts. So the first concept which we are going to see in the chapter of probability in second PUC is conditional probability. Okay, now remember, This is actually a very basic concept. Let us see the definition and I'll explain you what it means. If E and F are two events, just now I told you, we come across many words here. If E and F are two events associated with the same sample space, again, the word sample space. So I repeat, if E and F are the two events associated with the same sample space of a random experiment, as I told you, again you get a word random experiment here, then the conditional probability of the event E given that F has occurred. You denote this by probability of E given F, or you call it as probability of E conditional F. You don't call it as E bar F. Rather, though you write it as E bar F, you call it as probability of E conditional F or E given F. So what do you mean by E given F? Probability of event E given that F has occurred. Okay, so the formula for this probability of E given F is nothing but probability of E intersection F divided by probability of F. Provided we know probability of F cannot be 0, because if probability of F is 0, then this would be not defined. Is it clear? Now you might be wondering, what is this conditional probabilities? It's very simple, dear students. I know most of you, all of them are second PUC students, I hope, watching this video. Now let me say, each of you have passed 10th standard mathematics 100% sure, isn't it? So now, keeping in mind that you have passed the 10th standard mathematics, now if I ask you what is the chance of you passing the second PUC mathematics, will be called an conditional probability. I repeat, let me assume F is the event that Raju has passed 10th standard mathematics. Okay, E is the event probability of Raju passing second PUC mathematics. So now the condition would be, what is the condition that probability of Raju passing the second PUC mathematics given that he has already passed 10th standard mathematics. Okay, so this is the very basic formula, my dear students. In this chapter you are going to get 1 mark question probably related to the same formula. Okay, very easy questions are there. We are going to see this see that in this session itself. Okay, remember, so probability of E given F is given by probability of E intersection F divided by probability of F. Okay, in case they would ask you probability of F given E. Okay, this is again very simple. Numerator there is no change. This would be probability of E intersection F, but only thing is, whichever happens first, you divide by probability of that. Okay, so probability of F given E would be probability of E intersection F divided by probability of E, provided what is the condition? P of E should never be 0. Okay, now this is a formula which you would be writing every time when you get a 1 marker question. The same question can be asked in your problems. You will see that he will ask you probability of A given B or A conditional B. Again, there is no change, just change the variables. So probability of A given B is nothing but probability of A intersection B divided by probability of B. Are you following, Aishwarya? Right. Similarly, now probability of B given A. What is probability of B given A? We know that probability of B given A is, yes, Suchitra, can you tell me? It is same probability of A intersection B divided by probability of A. Isn't it? Very simple. Now provided in this case, your probability of B should not be 0, otherwise it would be not defined. Similarly, in this case, your probability of A should not be 0. Okay, very simple, isn't it? Kindly remember this formula, because now you're going to use this to get your 1 marker questions. Okay, right. Okay, students, we'll go through the properties of conditional probability next. Okay, so going through the properties of conditional probability, the first property says this: if E and F are events of a sample space S of an experiment, then we have probability of S given F. Remember, S means sample space. Probability of sample space given F, or probability of any event given the same event, would always be an sure event, because the numerator would be F intersection F. We know F intersection F is F itself divided by probability of F. Both would be same. You would get cancel and get 1. This is a trivial result in coming to conditional probability. Going on to the next one. If A and B are any two events of a sample space S, and F is an event S, such that P of F is not equal to 0. Remember, I will consider F, which is another event, such that it is not a impossible event. What do you mean by a probability of any event equal to 0? It is an impossible event, but I am not considering an impossible event. Then probability of A union B given F. Probability of A union B given F is probability of A given F plus probability of B given F minus probability of A intersection B given F. Now, before I explain this, let me just go through the basic formulas of probability which we have already learned in the first PUC. So the first one is probability of any event A will lie between 0 to 1. If it is equal to 0, it's called an impossible event. If it is exactly equal to 1, it is called a sure event. Now next, going to the next formula, probability of any event plus probability of not happening that event, both will be equal to 1. Okay, so if 1 is given, I can find the other one. So probability of not happening an event is 1 minus probability of an event. Now going on to the next question, you might have seen this in the chapter of sets, isn't it? We have used n of A union B is equal to n of A plus n of B minus n of A intersection B. The same formula would be applied even for probability. So probability of A union B is equal to P of A plus P of B minus P of A intersection B. Now compare this with the conditional probability. The same formula holds good even for conditional probability, given that F is another condition or F is an event. So compare these two. So probability of A union B conditional F is probability of A conditional F, probability of B conditional F minus probability of A intersection B conditional F. Now the next property, the third one, which follows directly from here, probability of not happening an event is 1 minus probability of happening an event. Similarly, probability of not happening an event conditional F is same as 1 minus probability of happening an event conditional F. Okay, so dear students, I hope you have not got confused with the basic definitions of probability. Hope you are not bored yourself also, because for me to explain you the problems part, you have to know the theory part properly before getting into the problems. So dear students, I'm not going to stop here. Rather, we're going to start this session now with the 1 marker question of your probability chapter. Okay, if you once we started, you will find this is one of the easiest question to get 1 marks. Okay, shall we start? Let's go to the first question, which was asked in the year March 2014 for 1 marker. Remember, the 1 marker question from this chapter would be the 10th question in your part A, that is the last question also. Now look here, if P of A is equal to 4 by 5 and P of B given A is equal to 2 by 5, find probability of A intersection B. Okay, now don't get confused over this. Now you can see here, look at the data. He has given P of A, let it be so. He has given P of B given A. Whenever you find that such kind of problems, just take the formula related to that conditional. So we know that, as I just told you some minutes before, we are going to use the formula so probability of B given A is nothing but, yes, what, Raju? It is probability of A intersection B or B intersection A, whatever you can write, divided by, remember, it is probability of A, isn't it? If you know this formula, you can easily get 1 mark. Therefore, probability of A intersection B is nothing but probability of B given A into probability of A. Okay, this would be a very easy formula. This is nothing but probability of B given A is already there. You need not write the data because this is just a one marker question into what is P of A. He has given it as 4 by 5. So kindly please multiply, dear students. Now multiply the numerators. 4 2s are 8 divided by 5 5s are 25. So very simple answer. You're going to get 1 mark if they ask you this year again. Okay, very basic solution. This is only one thing you have to remember is the formula, the conditional probability formula. Okay, most of the questions which has been asked in for 1 mark is related to the conditional probability. Okay, so shall we move on to the second question? So look at the second question. He has given probability of A is 0.6, probability of B is 0.3, and probability of A intersection B is 0.2. Find probability of A conditional B. Asked in the year July 2014. Okay, remember the same question has been asked twice in September 2020 and March 2009, but with the events in place of A and B, he has given E and F. Even then, it would be the same solution. Okay, so let me consider this. So probability of E wants A conditional B. So as I told you, let us use my formula. Probability of A conditional B would be nothing but probability of A intersection B divided by probability of B. Okay, so this would be nothing but in a single line you can write the answer. What is probability of A intersection B? He has given 0.2 divided by probability of B. Please be very careful, dear students. Now you might be wondering, why has he given probability of A? It's very simple, just to confuse you. Okay, don't get confused. Just use the formula. Whatever you want, just consider. The unwanted stuffs, just leave it as it is. So this would be, if you can use your calculator, you would actually get 2 by 3, or you can write it as 0.666. It just moves on. Okay, this is how you get probability of A given B. In case they ask you for the same question, probability of B given A. In that case, it would be probability of A intersection B divided by probability of A, remember. Then we need this value. Okay, so this would be nothing but 0.2 divided by 0.6. This would be nothing but 2 by 6. Okay, so you can use your calculator. Please don't worry. Your basic calculators are allowed for you. So 2 by 6 would be 0.33. So it would be 0.333. It would be a recurring decimal. Very easy, isn't it? Easily you can get 1 mark, but please be careful. Okay, in case, as I told you, they've already asked in terms of E and F twice. Let us also calculate this. So in case if E wants probability of F given E, so probability of F given E would be probability of F intersection E, or you can write E intersection F. That does not matter. But what matters is the denominator. Denominator is whatever the event here, the denominator is, use the same denominator. This is nothing but, intersection is nothing but 0.2 divided by P of E is 0.6. Okay, this, as I told you, if you use your calculator, you will get 0.33. Is it clear? In case they ask you probability of E given F, so it would be probability of E intersection F or F intersection B. Because intersection is commutative, you can use E intersection F or F intersection B. But what matters is the denominator, which is probability of F. This is nothing but intersection is probability is 0.2. Now, what is P of F? It is 0.3. Okay, so if you use your calculator, you get the answer as 0.666. Okay, very simple questions. If they ask you, you can easily score 1 mark from this part. Look at the third question, dear students. If P of A is equal to 3 by 5, P of B is equal to 1 by 5, find P of A intersection B if A and B are independent events. So this is the one question he has asked on the basis of independent events. Remember, the question has been asked 4 times. The same question, even the values are not differ. Okay, so I'll give you a hint before solving this question. The hint is as follows. What is the hint or the formula? You're going to see this in detail in the next concept. A and B are independent events. Implies whenever A and B are independent events, then probability of A intersection B would be nothing but P of A into P of B. Very, very simple formula this is. Okay, just remember the formula and just apply it. You're going to get the solution. Okay, now you can see here he has given a condition if A and B are independent events. So he has given the condition is if A and B are independent events, P of A intersection B is simply P of A into P of B. I want P of A intersection B, isn't it? So I'll use it. Therefore, P of A intersection B would be, kindly write the formula. Anyhow, you're not going to have the marks for formula in this case. So it is P of A into P of B. What is P of A? He has given it as 3 by 5 and the P of B has given it as 1 by 5. So this is nothing but 3 ones are 3 and 5 fives are 25. Remember, such an easy question which has been asked 4 times. So there are chances of again being repeated. If it is repeated, you are lucky enough because it's a very simple question and the solution is as easy as the other one. Okay. So the fourth question we have is if P of A is equal to 0.8, P of B is 0.5 and P of B given is A is 0.4, then find P of A intersection B. Okay, this question has been asked twice. Okay, now remember I cannot directly write the formula for A intersection B, but he has given the conditional B given A. Therefore, write the formula for probability of B given A. So probability of B given A is probability of A intersection B divided by, remember, it is probability of A. Okay, therefore we'll cross multiply it. P of A into P of B given A is nothing but probability of A intersection B, isn't it? Just by cross multiplication. Or you can write the same formula as probability of A intersection B is nothing but simply probability of A into probability of B given A. So this is nothing but, what is probability of A? He has already given as 0.8, okay, into probability of B given A is 0.4. So this would be nothing but, use your basic calculators, 0.8 into 0.4 would be nothing but 0.32. Okay, don't call it as 0.32. After decimal point you have to split the terms. You have to call it as 0.32. Okay, very simple, isn't it? I hope you are enjoyed seeing this kind of questions for 1 mark, and you would be lucky enough to get 1 marks for this kind of question. Don't say probability is a very difficult chapter. Actually, it is one of the easiest chapter in your second PUC mathematics or any class mathematics. Now the next question we have is actually the same question. Just we did the fourth one. Only thing is there the unwanted value was given there. Here he has directly given the wanted stuffs. He has given P of A. He has given P of B given A. He wants me to find out P of A intersection B. Okay. So let me write the formula. Always don't go for A intersection B. First consider the conditional probability which he has given. So he has given B given A. So probability of B given A is probability of A intersection B divided by probability of A. Okay. Therefore, from this you are going to get probability of A intersection B is nothing but, by cross multiplying, you will get P of A into P of B given A, or you can either write it as P of B given A into P of A. Whatever it is, since it is multiplication, it is commutative, need not worry. What is P of A? P of A is 0.8 into P of B is, B given A is 0.4. if you multiply using your calculators, again it is the same question, so you're going to get the same answer, 0.32. If you can solve this, you will get 1 marks into your pocket and also into your mathematics subject. So the next question has been asked twice, July 2016 and March 2018. P of A is given, B is given, A intersection B is given. He wants me to find out probability of A given B. Okay, just use the formula. Probability of A given B would be probability of A intersection B divided by probability of B. Okay, this is nothing but, he has already given probability of A intersection B is 4 divided by 13 divided by probability B is 9 divided by 13. Okay, so you can cancel the terms because you have common denominators. You would simply get 4 by 9. It would be enough for you to get 1 mark if you can get 4 by 9. Or else you can use your calculators and write the decimal form. 4 by 9 would be 0.444. Okay, the same problem. Let me assume if he asks you probability of B given A, then let me find out that question also for you. Probability of P given A would be probability of A intersection B divided by probability of A in this case. Okay, so this would be nothing but, intersection wise the value would not change. It is 4 divided by 13 divided by P of A would be 7 divided by 13. Okay, so denominators gets cancels. You will get 4 divided by 7. This is enough for you to get 1 marks, or use a calculator and write the decimal form as 0.5714. That's enough actually. If you write 0.57, that would be enough for you to get 1 mark. Very easy question, isn't it? Will you get 1 mark for this if they give you in the examination? By all means. Okay. Yes, we shall move on to the next question. In the next question, he is given P of P. He is given P of A intersection B. He wants P of A given B. A very simple question. Just use the formula. So probability of A conditional B, as you all know, yes, Shreyas, what is the formula? It is probability of A intersection B divided by probability of B. Okay, so this is nothing but, A intersection B would be nothing but 0.32 divided by probability of B is 0.5. Okay, so this would be nothing but, use your calculator and write the answer as 0.64. Okay, so this question was asked in the year July 2018. Such a simple question, dear students. Kindly don't blindly say probability questions are difficult. Rather, they are very easy questions. Okay. The next question is a challenging question which was given in the second set of the paper in March 2018. This was not given in the year March 2018. Rather, it was given for a practice paper in the March 2019 preparatory. Okay. If A and B are independent events, find A given B. If I want A given B, remember, I want intersection, probability of A intersection B. But he has not given me probability of A intersection B. Okay. But he has given the condition independent events. So because the events are independent, probability of A intersection B would be nothing but probability of A into probability of B. Isn't it? We've already seen this in the second question there. So P of A is 0.3 into P of B is 0.4. So this would be nothing but 0.3 into 0.4 would be nothing but 0.12. Okay, so if you have any doubt, just check your calculators. So once P of A intersection B is got, I can directly go on to for my required process, probability of A given B. Okay, so probability of A given B is probability of A intersection B divided by probability of B. This is nothing but A intersection B I have is 0.12 divided by probability of B is, please be very careful, it is 0.4. Okay, this is nothing but 0.3. Okay, Now remember, for the same question, if they ask you B given A, just use the same thing divided by 0.3. Okay, in that case you will get 0.4 as the answer. I repeat, if they ask you probability of B given A, then it is probability of A intersection B divided by probability of A. Okay, so it would be 0.12 divided by 0.3. So the answer would be 0.4. Okay, right. Very simple question, and we shall move on to the next one. So look at the next question. If P of E is equal to 0.6, P of F is given, intersection is given, E wants P of E given F. Okay, so probability of E given F is nothing but probability of E intersection F by probability of F. So this is nothing but, intersection is nothing but 0.2 divided by P of F is nothing but 0.3, that is nothing but 2 by 3. So it is 0.666. Okay, similarly for the question, if he asks you probability of F given E, condition is very same, probability of E intersection F divided by 2 would rather be probability of E in the denominator. So this would be 0.2 divided by probability of E is 0.6. So you will actually get 2 divided by 6, that is nothing but 0.333. So 0.333. Okay, right. Well, students, let us take one more question before winding up this solution. Okay. So look at the next question, the last question for the session. If P of A is equal to 1 by 2 and P of B is equal to 0, remember, he is telling me to find out P of B given A. Okay, because P of B is 0, which means an impossible event, the probability of B happening provided A has already happened. Remember, whether A has already happened or A does not happen, since P of B is equal to 0, we can say P of B given A is also 0, because you can say B is an impossible event. Okay, you have to say B given A is an impossible event. Okay, now so that's the answer. You just say P of B given A would be 0. Okay, this was not asked for the standard question in your year, any years. Rather, this was asked in the March 2019 second set question paper, which was given as a preparatory paper. The same question which is in the textbook, he has asked you probability of A given B for the same question. Okay, now remember, probability of A given B is, if they ask you probability of A given B, remember, probability of A given B is nothing but probability of A intersection B divided by probability of B. Now because, look here, because probability of B is equal to 0, this is not defined. Okay, so you can say this is nothing but not defined. You might say the reason why this probability of A given B is not defined, because you have to say P of B is equal to 0. Okay, just always remember the condition of the probability which we started up in the beginning of the session. So remember, probability of A given B is probability of A intersection B by P of B, but the case is P of B should not be 0. If it is 0, as in this case, we say the probability is not defined. Okay, very simple, isn't it? Okay, students, so we're going to wind up this session here, and before we go up to the next sessions, I want you to just go through these problems and practice this, so that 1 mark should be like a fixed deposit in your marks card, particularly from mathematics. Okay. ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನಮ್ಮ ಇಂದಿನ ಸೆಷನ್ನಲ್ಲಿ ಪ್ರಾಬಬಿಲಿಟಿ ಚಾಪ್ಟರಲ್ಲಿ ಇದ್ದಂತಹ ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾ ಡೆಫಿನೇಷನ್ಸ್ನ ಜೊತೆಗೆ ಈ ಚಾಪ್ಟರ್ಲಿ ನಿಮಗೆ ಬರಬಹುದಾದಂಥ 1 ಮಾರ್ಕರ್ ಕ್ವೆಶನ್ಸ್ನ ಪ್ರೀವಿಯಸ್ ಕ್ವೆಶನ್ಸ್ ಪೇಪರ್ ಆನ್ಸರಲ್ಲಿ ಎಲ್ಲ ನೋಡಿದ್ದೀವಿ. ಹೆಚ್ಚು ಕಡಿಮೆ ನೀವು ಇಷ್ಟನ್ನು ನೋಡಿಕೊಂಡ್ರೆ ಈ ಚಾಪ್ಟ್ರಲ್ಲಿ ನಿಮಗೆ ಬರುವಂಥ 1 ಮಾರ್ಕ್ಸ್ ನಿಮಗೆ ಸಿಕ್ಕಿದಾಗೆ. ಸೊ ದಯವಿಟ್ಟು ಇದನ್ನು ನೋಟ್ಸ್ ಥರ ಬರ್ಕೊಳ್ಳಿ. ಈ ಪ್ರತಿ ಪ್ರಾಬ್ಲಮ್ನ ಬರ್ಕೊಂಡು ನೀವು ಮಾಡಿ, ಬರೀ ಇದನ್ನು ನೋಡಿದ್ರೆ ಸಾಲಲ್ಲ, ನೀವು ಮಾಡಿ, ಆಗ ನಿಮಗೆ 1 ಮಾರ್ಕ್ ಆರಾಮಾಗಿ ಸಿಗುತ್ತೆ. ಓಕೆ. Okay, students, I hope you would have enjoyed this session and also learned the very basic concept of conditional probability. Okay, so we'll meet you on in the next session with the next topic. Until then, take care and bye.